Hey everyone, it's Stephen here from rConfig, back with you for another tutorial video. Man, it seems like ages since we did a few tutorial videos, but we've had a lot of feature releases in the V7 track recently. So it's time to get some knowledge out there and some information about how we've improved the product over the last couple of months. Today I'm going to focus on queuing in rConfig. So it's one of our best features and kind of hidden secret features, if I can put it that way, in terms of our ability not just to multi-process and download configurations from devices really at speed, but our ability to scale across really, really large networks very rapidly. So I'm going to talk through a couple of things. I'm going to talk through the kind of default V7 professional setup from a queuing perspective. We're going to set up a whole bunch of devices and monitor that for a few moments. And then we're going to make a change and we're going to watch queuing the speed of download in terms of concurrency and multiprocessing just explode. So hold on, this is going to be a lot of fun. Okay, so the first thing we're going to do is get logged into V7, which I have here in my development box right in front of me. I'm just going to show you a couple of things. So this is kind of a out of the box setup. It's our kind of lab environment, but I just want to demonstrate a couple of things and then we'll get into it. So we'll see here we kind of have a bunch of devices, 18 in total. I'm going to turn on my nice little mouse cursor thing. There we go, highlighter. So we have about 18 devices in total. And the device I'm going to focus on today is the Radware application delivery controller. So if I go to vendors, we've got a Radware vendor. If I go to tags, we've got a Radware tag right there. And what's kind of cool about this video today is we're going to mix a couple of features together. So we have a Radware category on the next page, I think. We have a couple of Radware categories. Sorry, somebody saw it now and I did not. They're right here in front of me. So we have a Radware category 1, which is working, which is attached, which will attach to the device, and we have a Radware category 2, which is kind of a dummy one, which we won't use. Critically, this Radware category 1 has 3 commands associated with it, and they're actually script integration commands. So our script integration feature is a brand new feature in V7. If I just bring up docs here real quick, just to show you where the details for that are. It's basically a groundbreaking feature that allows you to bring any language to rConfig for the purposes of backup or automation. Not going to get into that today, that's a different topic, but just know that we're using our script integration feature. So we're going to call an expect script which connects to the device and downloads it. Now, what are we going to do? So the first thing we're going to do is seed 5,000 devices into rConfig. And luckily, like every good chef, here's one I prepared earlier. So I have a little commandlet here in rConfig that's going to allow me to seed 5,000 devices into rConfig in just a matter of seconds. So hold on to your hats. Here we go. And that's it. 5,000 devices seeded in with templates, vendors, categories, the whole lot attached. Let's just refresh our page here. And we can see we're now up to 5,000, well, technically 4,999, but we've added 5,000 devices. We'll keep the number round. For demonstration purposes, let's just pick one of these at random. We see we have no downloads, no configs here, so let's do a quick download. And I want to demonstrate the kind of download time and do some extrapolation before we actually do the test. So we did a download, it was done real quick. If I refresh the panel down here, we have 3 commands, we have 3 configs to view. Perfect. So we have our Radware ADC, which is kind of like an F5 load balancer, I guess. Just 3 different commands that we've downloaded here. So that's all good. Perfect. Okay. So what we can also then observe, so if we go to our queue manager, which is one of the places I'll often tell you to go to look for troubleshooting and queue processes and different things. So open the Horizon dashboard, and if I go to completed jobs, we'll see that job was completed in about 2 seconds. All right. Now I'm going to do a little bit of math for the Americans and maths for the Irish and English and Europeans. So extrapolating 2 seconds times 5,000 devices If it was strict, if the jobs were strictly done in serial, so let's do a bit of math, right? So 2 times 5,000 is 10,000, so that would be about 10,000 seconds. What does that equal to in minutes? I have my handy time conversion calculator here, so seconds to minutes, so let's say 10,000. Calculate, that's about 166 minutes. Now, just pause a second. That is if every single device was downloaded in serial one after the other. They're not. Okay, and I want to show you something else. The out of the box, the default for rConfig is, and I'm going to bring up the code base here for 1 second, if I can find what I'm looking for. Actually it's in docs. Let's go to docs, settings, queue manager. If I just scroll, read all of these, they're all really important. The default is 10 max processes. Okay, so that means 10 concurrent jobs at a time. All right, that's what's going to happen. So let's do our math again. So if we say 2 seconds, sorry, no, let me just complete a job. So 2 seconds times 5,000 is 10,000 divided by 10. So let's just say it's strict concurrency, 10 at a time. Okay, so 10,000 seconds divided by 10 is going to be 1,000. So that's, calculate again. Okay, 16 minutes. Let's just say 10,000 devices at 10 jobs per sec concurrently is about 16 minutes. So let's see. All right, let's see if we can match that. And then let's see if we can increase it. Okay, so to verify the overall time for 5,000 device scheduled task that will run at 10x concurrency, let's create the scheduled task. I did create one in here earlier, but let's go ahead and do it again because I want to demonstrate the whole thing end to end. So we're going to create a task. We're going to add it to a tag. We're going to call it queue test one. We can just copy that. That's fine. And then we're going to select our tag being Radware tag, surprisingly enough. We're just going to turn off email notifications. And now I'm going to set this to some far out there time, like once a year, right? Because I'm going to run these jobs manually. So say that's all fine, all good, save the task, and we have our Q test here. Now let's quickly jump back to Horizon, look at the dashboard. Nothing is running at the moment. We just had that one completed job. There's nothing in batches, right? So let's run this. Start, run, head back to Horizon, and we should, there we go. Okay, so I just had to pause the video for a moment because the status came in as completed right away, but actually it flipped over to pending almost immediately, right? So we're going to just observe some metrics. We can see completion is 2%. We're looking at pending jobs, and what we're going to see in pending jobs, ignore these make searchable ones. We're going to see, and I'm going to, this button up here is auto load entries, right? So it's going to auto load the data for us. What we're seeing is downloads, config change jobs, like there's our downloads, right? So we're going to see lots of them going through. What I'm more interested in is up here on the dashboard. Now, let's have a look, right? So our processes for the task download queue, which is where all jobs go, our current max processes is 8. Now, the way Horizon works, and it's in the documentation up here as well for Laravel, um, we have it set to an auto balance kind of algorithm, which it does balance jobs across different queues depending on resource utilization of the box, etc. So we can kind of see we've gone up to 20 processes. So I said our default max is 10. Well, that's 10 under an auto balancing algorithm where if the box is otherwise busy and doing other things, it will peak at 10. But look, it went up to 20 because it realizes it has some more queues and processes to spread the load across. And that's kind of cool, right? So it's not strictly 10. It will go over a little bit, but you can see it's adjusting here as more jobs are coming in, as more jobs are emptying out of the queue, it is adjusting itself. So that's cool, right? What we're also seeing is the wait time for the job. So that's the wait time for the last job in the batch to go through. And look, Not a strict science, but not very far away from our 16-minute calculation here. And we will see this go down over time. Now, we are not going to wait 18 minutes. We're not going to watch paint dry and see uh, watch this complete. So what I'm going to do is pause the video and come back towards the end, and we'll pick it up from there. Now I'm picking this up again mid task just to make a couple of observations while it burns down like 5,000 devices in this task. So the batches has reduced. We do have some failures. It's worth pointing out that I'm not hitting a real Radware ADC. I'm hitting a Linux server that's set up to mimic it. Um, and while the SSH kind of max concurrent count is set way, like really high, I'm not surprised that some of the jobs are kind of dying. But that's okay, I guess, if you have a task that is all individual network devices, like you're only hitting those devices once for a config backup, so you shouldn't be experiencing these timeouts. It's also indicative of, like, if you are hitting devices that are not responsive or different things, right? That because of the max concurrency, like the rest of the jobs in the queue carry on. So it's not in serial, so the entire job, the entire task duration isn't affected, which is kind of nice. One or two more things to point out. The jobs per minute has just jumped enormously. Now I'm expecting on the second run of this, once we make our adjustment, for this to be massively higher. But 554 jobs per minute seems high at 2 seconds per download, which we observed at the start. Actually, it's probably not that high. So again, with the with the balancing algorithm, we still have 3,000 jobs to go at 8 processes, but with the balancing algorithm, which can touch other queues, and I do know that this metric can be latent, so it's compounded over time and not a strict point in time. There's now 500 jobs, there's now 600 jobs or whatever. It's aggregated over time, and you can observe the metrics here in a queue-like manner. So you see the way it kind of ramps up over time as well. Um, but it's more indicative, right? It's not a strict calculation on a per second or per minute basis. Okay. So let's wait another few moments. Like we're kind of on track. 16 minutes left, so let's wait another few moments. Let me come back when it's close towards the end. About 2,800 devices left. Perfect. About half to go. All right, perfect. So we're burning down the last few devices here. You can see still up. There it goes. Right. Last 39 jobs. It's delayed processes. Still, that jobs per minute's kind of fluctuating. 11,000 jobs. Um, the number there does not reflect actual device downloads. It's accumulation of device downloads and other system jobs which run, such as config diffs and different things. Um, with 7 failed jobs. So let's have a quick look at the batch. Yeah, so like 1, 2, 3, 6 failed jobs. That's pretty good, considering it was 5,000 jobs. Now listen, this is a sterile environment. We know the device we're hitting, everything is set up for maximum efficiency in terms of the device. In the real world, 5,000 devices might take several hours. It really depends on size and quantity of configs, number of commands, latency less so, but can a little bit, um, device responsive time and different things, right? So 16, 18 minutes per calculation is pretty good, right? But what if you wanted to go faster? That's the question we're going to answer today. So on the rConfig docs right here, I hope you read all of the queue manager documentation. There's really only one change we're going to make, and we're going to make it on our environment variable file, and that is this one. Excuse me, the Horizon Max processes value. Okay, I'm going to do this in VS Code. You can do it on the command line, and you do need to run the rConfig clear all command afterwards. Okay, so let's bring in VS Code. Again, you can do this on the command line, just using vim or nano. So open your .env file, which will be in your current directory or your persistent data slash storage persistent data directory. You can see the default value for Horizon Max processes is 10. Now, older versions of rConfig probably won't have this, so you may need to add the key specifically. But again, read docs on Queue Manager for all of the details, or reach out to support if you need to. Now, with a few runs of this video, um, if you set this value, from experience, if you set this value too high, you will kill your server. Okay, so our recommendation from a support perspective is two things. One, get your server into monitoring. Okay, if you're not monitoring CPU and memory on the server, you should be. You can see where we ran that earlier test, and I've had a few runs of the video since, but we did peak out RAM at almost 30 gigs out of a 32 gig server, and the CPU definitely spiked up to almost 100%, actually 100% a few times. That's not the only issue though. Database connections and other things come into play as you tell the underlying dependencies that you're going to consume that many processes. So be careful about changing this value. Change it kind of in small increments, okay? I think for this demo, I'm going to increment it to 50. I think should be a safe enough number, 50 max processes, and let us see kind of what happens here. Okay, so I've set that to 50. I now need to bring up my command line, and I'm going to run a PHP artisan rConfig clear all. This is all over the docs, and if you've not done this, you should know what this command is. Clears out the application cache, kind of rehydrates the application cache with any updated values. So that's fine. And then if I go back to, ignore that, that's from a little while ago. If I go back, log into the application, we still have our task. Now, what will have happened here then is our cur queues will have hydrated with new processes available to them. Okay, so these numbers are different to earlier. They will change. It is based on the balancing algorithm, which is set to auto, right? So what we're going to do now is we're going to kick off the job, and I think we're going to see the total processes. Well, the total processes has increased to 50, so that's cool. And then we're going to see the jobs per minute increase dramatically, and we're going to see the wait time, which we saw here, varying from 16 to kind of 20 minutes. That should be a lot less. So let's give this a go. Okay, so very simply head back to the rConfig v7 professional user interface, go to schedule tasks, and let's run that task again. So knowing that we've got 5,000 devices in there still, let's start it. And we're just going to observe the queue manager horizon just for a few minutes. So let's go into batches. Okay, so we saw earlier that it kind of comes in as finished because it has yet to calculate the sizes, right? That's why it comes in as finished initially. Once it calculates that, there it goes. It calculated the size and then sets it to pending. So that's good. Now it's going to run the job, and it's going to run it under the new conditions of 50 concurrent processes available to it. Okay, so first thing to do is head back to the dashboard, and now we're seeing 16 minutes as the kind of wait time, right? Now I'm expecting as the jobs per minute increases, so our kind of max on the previous run was like 600. I'm expecting this to ramp up quite a bit more. We can see our total available processes decrease significantly, and that's all in line. Now what we're also observing is our wait time now is below 10 minutes. So let's do a quick back of the envelope calculation while this is running, right? So we said initially, we said, let me just not bring that up. I want to bring up Notepad. So we said, one second, serial, 2 seconds per download times 5,000 devices equals 10,000 seconds, okay? At 10 concurrent, which is the same as this, divided by 10, which equals 16 minutes. That was 166 minutes, okay? Minutes. And then, my typing is terrible. And then at 50 concurrent, which is this, which is 10,000 divided by 50, which is what? All you great mathematicians out there, quickly, and it is 10,000 divided by 50, 200 seconds. 200 seconds. Let's see. Is that correct? It probably is. Well, we're already down to 6 minutes, so I don't believe 200 seconds. I think that's a bit too severe on the system, and I think there's other things going on in the system. Uh, Queues onboarding to the processor and memory queues offboarding. So there's all those kind of things, right? So I don't think 200 seconds is it's too sterile, right, for it to be exactly 200 seconds. Is that correct calculation? It's not 2000 seconds. No, it's not. That would be divided by 5. Okay. Um, it's still significantly faster. Look at our jobs per minute. They doubled at least. That might even go up higher. Total processes now has ramped up to 88, so that means we're consuming a lot of CPU memory. We're getting those jobs down really fast, right? So let me look at system resources, and we can see CPU is ramping up. Disk I/O is ramping up because we're writing all those config files to disk. Just making a more of an observation. So we're now almost 3 times the previous attempt. 101 processes. So we're ramped way up. You can see it is balancing across the queues. This is what I keep saying, right? It's not a strict maximum. It will balance where it can, and that's probably why it falls over. And that's the auto strategy we have now. We do have other strategies that we could use for balancing, but we're sticking with auto for now. We've hard coded it into the application. Um, I don't think there's a need to change it. Let's come back in a moment and see how this progresses. All right, so we're coming close to the end. 500 jobs left. Still, like, jobs per minute is through the roof compared to where it was on the last run. Up to 100 kind of concurrent processes. Now, again, it's over time and it's not strictly linear, but demonstrating the numbers, looking at 2,200, maybe 2,300 jobs per minute at the peak compared to the original task, which was 10 max processes. We peaked at about 600 jobs per minute. So look, we're going to watch this burn down while I kind of just conclude and wrap this up. So we moved from a default of 10 max processes on Horizon to 50 max processes. You saw the jobs per minute went from kind of 600 up to like 2,300. You could go more on higher spec boxes. There's a few permutations to take into consideration as you increase the queue value, the max processes queue value, job timeouts, uh, device latency, and I don't mean network latency, but the latency of devices to respond to tasks, the size of configurations, all these kind of things play into the overall jobs per minute value, the total amount of processes that are consumed. If I look at the batches here, now this finished 100% green compared to the last one, which there was failures, but you might have failures which will hit timeouts. We did see earlier on this batch there was 30-second timeout. So again, all of those things play into the overall calculation of jobs per minute and the balancing algorithm. So it's not a strict science, it's a little bit of an art. But the key thing that we demonstrated today is the ability of rConfig to scale massively. One of the other things we didn't see here is running tasks concurrently. Okay, so if I ran, let's say, if I had 3 jobs concurrently, let's say 500 devices each, they will be balanced in the same way across the queues, right? 3 jobs, 500 devices, that's 1,500 devices, irrespective of the number of batches. Each one of those, whichever one starts first, starts consuming the queue first. So all of these things to take into consideration. The upshot from my perspective is there's massive scale potential here to get backups, configuration backups from your networks, any number of downloads of devices in a very short period of time. So final check, we should have multiple downloads for each of these devices. We do. We have got 6, right? 1, 2, 3, 4, 5, 6, and you can see the different times here. Half an hour in between because I was messing around with queues and different things, but you can see, and we have our updated versions and all that. So look, I hope this video was valuable. final word for me, it's a very, very powerful, very scalable feature, but it does come with a little bit of a health warning. Scale slowly, observe your resources on the server. If you're uncertain, raise an rConfig support ticket. I hope it was useful. Chat to you soon, guys. Bye.